Hello everyone. Today we are going to look at assembly on the TI-83 Plus calculator again. We have shown how to do Hello World 3 times now. Granted, slightly different reasons for each time. First time was getting set up. Second time was explaining what on earth's going on. Third time was showing that you can do it on the calculator directly. So now that we've shown how to output, let's actually get user input. We're going to use GetKey, which is a system call, to get the code for a key. How exciting is that? So before I get too terribly far, please do like and subscribe. The more you like, the more likely the video will show up for others so that we can share the love. And also, I haven't officially said it other than in the little description. Whenever you work with assembly, especially on calculators, there is the chance that you could have your RAM clear. That is common. If you type in something wrong, it will clear the RAM out. So if there's anything that's not archived, it is gone. So that's a warning about that. Also, it is possible that you could brick the thing. I mean, normally it'll turn itself off. You turn it on, the RAM clears. Worst case scenario is you take the batteries out and put the batteries back in and then turn it on and the RAM clears. Really bad, I guess you might have to take the little button battery out as well and then put that back in and then it will clear the RAM. I've never actually seen or heard of anybody flat out bricking their calculator, but warning, it's possible. Don't blame me. This is kind of like the MIT license on software. Do whatever you want with this knowledge and have fun with it, but there's no warranty or implied warranty or all the other fun stuff that it says. So if you break something, it's not my fault. Yay! Okay, enough of the legalese stuff. Let's actually get into the fun part, which is writing code. So starting out, let's just do an input.asm, and we're going to need that stuff that we always need at the beginning. So we're going to need to include our TI-83 plus include file. We need to specify our origin point. Don't forget the tab. User mem -2 and db. It has not picked up yet the auto include stuff that I would like it to. So T2 byte, there you are, my friend. And after that, we're going to also include T, there it is, ASM CMP, showing that this truly indeed is an assembly program. After that, we're probably going to want to clear our screen. Can do clear LCD full or clear screen full. They're obviously slightly different. I don't know exactly why they're different, but if you do look in the include file, they have different numbers associated with them. All right. So let's teach you guys something, a little handy trick. We're going to load into HL0. So up to this point, we've primarily worked with A, but with HL doesn't just hold a byte. It actually holds 2 bytes. So if you look at it, 1, 2, 3, 4, 5, 6, 7, 8, 4, 5, 6, 7, 8, this is what HL would hold, which is 2 bytes. Makes sense. The neat little thing we can do is if we look at our cursor row and we set that to HL, you might be thinking, well, cursor row only holds 1 byte and HL you just got done saying holds 2. So what will happen? Well, if we look, cursor row is right before cursor column, 844B, 844C. That means that it will actually store 0 in the cursor row, and it will automatically store a 0 in the cursor column. So that's handy. All right, after that, we're going to, well, at some point, we're going to want to get the actual key from the user. So let's do that B call, and it's called GetKey. Now, the way this works is whatever key you press on the keypad, it will give you back the number that is associated with that key and store it in register A for us. So somehow we want to display the value that is inside register A. Well, let's see here. If we do a B call and we do display, we can see that there is a display HL, and that's really all that there is that's any use to us. So, well, we need to find a way to take whatever is an A and stick it into HL. So let's do display HL, and now let's set up HL properly. So we're going to load into H0, and you might think, well, it already was 0 up here. Why are we doing this again? And the reason for that is behind the scenes, this block call will automatically do a bunch of stuff for us, but it also has to use the same registers that we have available to us, which means it's going to touch DE, BC, HL, and those values are not going to be anything that's useful to us. It's going to be whatever was last set in that register from the block call, so, or system call, whatever you want to call it. So we have to reset it. So we're setting the H to 0, and we're going to set the L to A, because remember, A is our return. All right. So just to briefly explain what's going on here, we're clearing the screen, setting HL 2 bytes to 0, setting both, there we go, really big, cursor row and cursor column to 0, getting the key, which is stored in register A, and then we display HL on the screen. Now you might remember before we did put string, and HL actually held an address in it. Well, we don't want to show what is located at an address and actually put that screen or that string on the screen. We want to display the value of HL itself. So that's why we're doing display HL. After that, we're going to do bcall, and we're going to do new line, and we're going to return control back over to the operating system of the calculator itself. So let's run this spasm inputs.asm, and we'll call it GetKey.8xp. Couldn't open the input file. Oh, well, there's not an S in input, is there? Okay, unknown bcall. Gotta love assemblers, they tell you stuff to help you out. Still unknown, helps if I save the file. There we go, success! Alright, so now we can use the linking program, we can put this on the calculator, we can test it out. However, that screen is still tiny, and I haven't found a way to, well, we can use that goofy magnifier thing again. But especially with this, it's going to be more interactive, because when you press the key, it's going to do things. And yeah, I mean, we're going to get the key, we're going to display it on the screen, and then there's going to be a run indicator that we want to get rid of. So let's do it on our emulator again. So we're going to try to do this in record time. And for those of you that missed that video, we are going to use the onboard assembler here, which is a program that you can get. I will just call it, let's do get, GET. That sounds like a good name. Now, there are different types here. Ion, that's a little bit before my time. Mirage OS, that's my heyday, and then we get into stuff after me. I talked about this on the Mimus video. I don't need to get into super details. Let's see if we can go a little bit more for speed than explanations. So I will turn on the caps lock on my keyboard, which should give me the ability to type, and it does. Okay, so clear screen full. If you would like to know how to actually go through the menus and do this on a calculator without the aid of a keyboard, I have an entire video on that, and it'll allow you to program when you want, whenever you want to have fun. So I would say take a look at that. All right. As always, it's always fun talking and typing at the same time and not typing the words that you're saying. You can see why I missed the underscore. Ooh. Syntax error. Why? Oh, I put a space in there. There we go. And return. All right, done. Menu. Compile. I think this is for PC stuff. We'll do it so that the PC can actually see it on the calculator. Actually, let's just quit out of here. Do we have a program? We do. We have a get program. Excellent. So let's assemble it. And there we go. There is our run indicator I was talking about. You can imagine how hard this would be with the screenshots, having to click refresh constantly to try to illustrate that this is moving. If we hit the up arrow, we get the number 3, and our program ends. Let's run it again. If we hit the down arrow, we get 4. If we hit log, we get 193. If we hit enter, we get 5. So each of these keys is mapped to a number, and that's the number that's displaying here. Now, I did promise you that we were going to get rid of that run indicator as well, or at least I should have. I don't remember if I showed you the agenda up front or not. I was probably so excited to get into it, I forgot to mention that. But why do something early when you can do it late, right? That's not the best motto in life, but we'll go with it. So let's go in, and I'll just do it on here since why do it twice? Oh, this is a good question. So can I do second insert? Oh, I can. Good, good, good. I like that. That's handy. Okay. Anyway, enough about this fun stuff. Let's do a B call. And the name of the call is run indicator, indic off. And I actually don't need an extra line in there. And you can see by changing the case sensitivity that it obviously recognized it. So let's compile it again. Okay. Yes, let's overwrite it. And quit out of here. Let's see here. Can I do second enter? Yes, I can. So now there's no run indicator. And obviously that's not a huge deal, but if you're making games or something, you don't want a distraction going on in the corner. And if you're doing assembly on a TI-83 Plus, you probably started by using TI Basic, or the basic default programming language that's built into the calculator, and you wondered how to get rid of that, and there is no way with Basic. So you can already do things that you could never do before. Anyway, that's all that I had for you today. I hope to see you in a future video. And again, please like, subscribe, all that fun stuff. I don't need to go overboard on that, but I just do want to remember it. And also, if you break your calculator, it's not my fault. Another positive thing to take away from this video. But in all seriousness, I hope you did enjoy this video, and I look forward to seeing you in a future video.